In this example, we have a train whistle that emits a sound at 700 kilohertz while traveling at 30 meters per second. And we want to know what the frequency the observer hears when the train is moving towards the stationary observer, and what the frequency is an observer hears when the train is moving away from the stationary observer. So I'm going to use my relationship that allows me to calculate the frequency an observer hears compared to what the frequency a source emits. Now for the towards example, I've taken my frequency and converted it from kilohertz to hertz by multiplying by 1,000. I know that the speed of sound, since I'm not told a temperature in the problem or any other medium, is going to be 343 meters per second. The observer is stationary, which means the speed of the observer is 0. And then we know that the source is moving at 30 meters per second because the train is the source of the sound. And when I'm moving towards, or the train is moving towards the observer, that is a positive 30 meters per second. And when the train is moving away from the observer, it's going to be a negative 30 meters per second, which is why you get a different answer for part A compared to part B. So in part A, you're going to get 7.67 times 10 to the 3 hertz, and for B, you're going to get 6.44 times 10 to the 3 hertz. We expect when the source is moving towards the observer that the frequency is going to increase, which is the answer that we got, and when the source is moving away from the observer, the frequency is going to decrease, which is what you see.